Hey students, today we'll start May-June 2024, paper 4, variant 1. Let's start it. Part 1 with question number 1. Name the process that is used to, okay, so we need to write the names of the processes. The name of the process which converts sulfur dioxide to sulfur trioxide in the manufacture of sulfuric acid. Very simple. To the manufacture of sulfuric acid, we have the process which is known as contact process. So we use contact process to make sulfuric acid. Then the process which obtains water from aqueous sodium chloride. Now, when we talk about aqueous sodium chloride, it means the sodium chloride dissolved in water. Sodium chloride in water. So it is completely soluble in water, completely soluble, and we want to separate water from it. We want pure water. So what do? We will do simple distillation. It depends that what do we want. If we want sodium chloride from the water, then we'll do crystallization. And if we want pure water to be obtained, then we'll do simple distillation. Then name the process that is used to extract aluminium from purified bauxite. So, extraction of aluminium from its ore, bauxite, we will use the process of electrolysis because aluminium is a more reactive metal. And for a more reactive metal, we extract them by passing electricity. The medium reactive metals can be extracted by simple reactions like displacement reaction or reduction by carbon. But the more reactive metals like aluminium, they can be extracted by electrolysis. The process which separates petroleum into useful substances. So to convert petroleum into different fractions, to separate them into different fractions, we use a process which is called fractional distillation. So fractional distillation is a process in which we separate liquids from its mixture on the basis of their boiling points. What's the process which produce ethanol from aqueous glucose? From the glucose, we prepare ethanol by the process of fermentation. Manufacture of alkenes and hydrogen from large alkane molecules. So when we have large alkane molecules which are of less use, we convert them into small chain alkanes, alkenes, or hydrogen by the process of catalytic cracking. Name the process which is used to separate a mixture of soluble colored substances. So when we talk about colored substances, then the separating technique which we use it is called chromatography. Question number 2. We need to complete this table. We have chlorine 737 and 17. So 17 is its atomic number, which is also equal to the number of protons. So the number of protons are also 17. For the number of neutrons, we will do the atomic mass minus atomic number. Atomic mass minus atomic number. For chlorine, the atomic mass is given in the question. We will not use the mass from the periodic table, but we'll see it from the table given. The atomic mass is 37 minus atomic number is 17, so it gives you the answer 20. As for the copper, copper is positive. It's a cation. It's a cation. It means it will be having one electron less than proton. Why? Because when any metal loses the electron, it gets a positive charge. So its electrons will be less than protons. Its atomic number is 29, so the number of protons will be 29, but number of electrons will be 28, one less. For the next one, the number of protons are 16, so whatever is the atom, it will be having the atomic number 16. You can calculate the atomic mass or the mass number by doing protons plus neutrons. So it will be 16 plus 17, which is equal to 33. So its mass is 33. You will identify from the periodic table that which substance is this. So 16 atomic number is of sulfur. So it's sulfur. And as you can see, the electrons are 2 more than protons. 2 more than protons means it has gained 2 electrons. So the charge will be 2 minus. It will be an anion, sulfide ion. Next, we have question number 3. This question is about the elements sodium and fluorine and the compound sodium fluoride. Sodium reacts with fluorine to form sodium fluoride. Write the symbol equation for this reaction. Now, the chemical equation is given to you, and you just have to convert this chemical equation into symbol equation. The sodium is Na plus fluorine. As for the fluorine, it's a halogen, and the halogens always exist as diatomic molecules. So we'll write F2 here. Na plus F2 gives NaF. Now, never leave any symbol equation unbalanced. It's compulsory to balance the chemical equation. For F2, if we write 2 over here, 2 on the products, then fluorine will become 2 on the products, but the sodium will also get 2. So we'll write 2 on the reactant side with sodium to balance it. Next question is, some properties of sodium, fluorine, and sodium fluoride are shown in the table. Explain why sodium conducts electricity when it is solid. You can see here, the sodium has a bit higher melting point. The boiling point is also very high. It's a good conductor in the solid form. Fluorine, its melting point is low, boiling point is low, and it's a poor conductor, obviously, because fluorine is a non-metal. So it will not conduct. Non-metals do not conduct electricity. Sodium is a metal, and sodium conducts electricity, but why it conducts electricity in the solid form? The answer is due to delocalized electrons. Electrons that move. Or you can also write mobile electrons. All the metals contain delocalized electrons, and these electrons are then responsible for the conduction of electricity. Complete the dot and cross diagram for the molecule of fluorine. Show outer shell electrons only. Now, whenever you have to draw the diagram of the outer shell electrons only, you can simply see that in which group they are present. In which group the element is in? Fluorine is present in group number 7. And as we know that the group number tells us the outer shell electrons. How many electrons will be there in the outer shell tells us the group number. So if the fluorine is in group number 7, that means it must be having 7 electrons in the outer shell. So it needs only 1 electron to get completed. Also, if we write the electronic configuration of fluorine atomic number is 9. If we write its configuration, it will be 2 and 7. 2 and 7 in the second shell, it has 7 electrons, so it means it needs 1 more electron to get completed. In covalent bond, The number of electrons they need, number of electrons they need is equal to the number of electrons they will share. So it's simply need is equal to share. The number of electrons they need is equal to the number of electrons they share. So as we can see, the fluorine needs 1 electron to get completed. So out of its 7 electrons, it will share 1. So one of the electron will be in the shared area and rest of the 6 electrons will be outside. They will form an unshared pair of electrons. In fluorine, there will be 3 unshared pairs of electrons and total 6 electrons, 6 unshared electrons on each fluorine. The same will happen with the next fluorine. 1 electron will be shared and rest of the 6 electrons will be unshared and will draw them outside. Because fluorine needs 1 electron, so out of outermost electrons, 7 electrons, it will share 1 electron and rest of the 6 electrons will be made outside. Deduce the physical state of fluorine at -200 degrees Celsius. Use the data in the table to explain your answer. Now we have to find out that what is the physical state of fluorine at -200. Let's see the table. -200 comes between melting and boiling point. Melting point is -220. Boiling point is -188. So -200, the temperature -200 comes between melting and boiling point. And after melting, before boiling, a substance is liquid. So it means fluorine is liquid at -200. So its physical state will be liquid. And the explanation will be that -200 lies between melting point and boiling point. Melting point and boiling point. Or you can also write that -200 degrees Celsius is higher than melting point, and it is lower than boiling point. You can write anything, -200. Next, explain in terms of structure and bonding why sodium fluoride has a much higher melting point than fluorine. Now, if we see the table, the sodium fluoride's melting point is 993 and fluorine melting point is -220. It's much higher. Why? Because fluorine is a nonmetal and it is a gas, but sodium fluoride is an ionic compound, and because of ionic compound, the force of attraction between its particles are very high. So it's a solid at room temperature. So its melting point will be higher. Now, what will we write? We have to explain the question in terms of structure and bonding. So we need to mention first that sodium fluoride has ionic bonding. While fluorine, which is F2, we just drew above that fluorine has a covalent bond between the two atoms, and covalent bond is comparatively weaker. While fluorine is a covalent compound, sodium fluoride has a giant structure. It has a giant ionic structure because we have to mention about the structure also. So it has a giant You can say it has a lattice structure, giant lattice ionic structure with strong electrostatic forces. While, on the other hand, fluorine is a simple molecular structure, simple molecular structure with a weak force of attraction, with weak intermolecular forces. That is why to melt or to overcome the forces of attraction in sodium fluoride will be more, or they need more energy, but fluorine needs less energy. Next question is about electrolysis. Dilute aqueous sodium fluoride undergoes electrolysis. Hydrogen is produced at the cathode. State what is meant by the term electrolysis. For the electrolysis word is the combination of two things. Electro means electricity, and lysis means breakdown. So, what will be the complete definition of electrolysis? Electrolysis is the breakdown of ionic compounds, breakdown of ionic compounds in molten or aqueous form, molten or aqueous form by passing electricity. Write an ionic half equation for the production of hydrogen at the cathode. Now, as we know that cathode is negative and hydrogen ion is positive. That is why hydrogen ion goes to the cathode. The positive ion means that it has a deficiency of electrons. So hydrogen ion will take up the electron and become hydrogen gas, H2. But hydrogen is always diatomic. So what we'll do? We'll take two ions of hydrogen, gaining two electrons and becoming hydrogen. This is hydrogen gas. And all the ions are aqueous. Next, question number 4. Hydrogen iodide thermally decomposes into iodine and hydrogen. The reaction is reversible. As you can see, hydrogen iodide is a colorless gas and it breaks into iodine, which is purple, and hydrogen, which is again colorless. But this reaction is reversible. Figure shows a gas range containing a mixture of hydrogen iodide, iodine, and hydrogen gases. The gas range is sealed and the mixture is heated to 300 degrees Celsius. Means the temperature. We are increasing the temperature of the system. The mixture of gases reaches equilibrium and is purple. Now, it reaches equilibrium, but it is getting purple, more purple. What is meant by the term equilibrium? Now, for the definition of equilibrium, we have to mention two things. First of all, we'll say a reversible reaction is in equilibrium when, now we'll write the 2 points. The first point is when the rate of forward and backward reactions become equal. Rate of forward and backward reaction become equal. And number 2 is when the concentration of reactants and products become constant. These are the 2 points which explain the term equilibrium properly. So we need to mention these 2 points, exactly these 2 points, whenever we define equilibrium to get full marks. The pressure of the mixture is increased. All other conditions stay the same. The position of equilibrium does not change. So when we are increasing the concentration, the equilibrium does not change. The color of the gaseous mixture turns dark purple. The temperature remains constant. Now, in this question, they are saying that we are increasing the pressure, but when we increase the pressure, the equilibrium position does not change, is not changing. But the color of the solution gets dark purple. It means that more of the iodine gas is produced. That's why the solution is turning purple. So what is happening here? Explain why the position of equilibrium does not change. It's very simple. As you can see in the equation, the number of moles on both sides are 2, 2. Hydrogen iodide is also 2, 2 number of moles, and for iodine and hydrogen, 1 plus 1 also becomes 2. So it means the pressure on both sides is equal. Pressure equal on both sides. If the number of moles are same, so that means pressure is also same on both sides. So what reason will give? Will not give the reason of the pressure. Will write about the number of moles, that the number of moles on both sides are equal. Are equal. After that, suggest why the color of the mixture of gases turns darker purple. Why it turns dark purple? Because the gas particles come closer to each other and iodine rate increases. The rate of formation of iodine increases. We'll write number one, it's just of 1 mark. So we'll write because the particles or the gas particles on both sides come closer to each other. And when they come closer to each other, iodine particles especially, when they come closer to each other, they form more purple gas, which makes the solution or the mixture dark purple. The temperature of the mixture of gases is decreased. All other conditions stay the same. The mixture of gases turns lighter purple. State what can be deduced about the forward reaction from this information. Now, the temperature of the mixture is decreased and the solution is turning light purple. So what can be deduced about the forward reaction? Now, in this type of question, mostly you have to tell that the forward reaction or the backward reaction is endo or exo. So let's find out. The temperature of the mixture is decreased and the solution is turning lighter. It means that when we are decreasing the temperature, the system is moving backwards. So when the system is moving backwards, it means that the backward side has more temperature. The backward side is exothermic because system will always do opposite of whatever we have done. Whatever change will do, system will act as to oppose that change. So if we decrease the temperature, system will move towards the side where the temperature is high. Means it will move towards the exothermic side. It will move backwards and the color will become lighter because hydrogen iodide is colorless. So purple color will become lighter. What is this telling us about the forward reaction? If the backward reaction is exo, then the forward reaction will be endo. So this is telling us that the forward reaction is endothermic. Deduce the oxidation number of iodine in Hi and I2. In Hi, hydrogen and iodide, hydrogen is always positive 1, so iodide will be negative 1. Because the positive and negative in every neutral compound, the number of positive ions and the number of negative ions are always equal. So here the iodide ion is -1. And in I2, in iodine molecule, when the element is present as themselves, as itself, means it is not combined with any other substance, in that case, its oxidation number will be 0. When the element is present or it exists as itself, then the oxidation number is 0. Methanol is manufactured by reacting carbon monoxide with hydrogen. The rate of formation of methanol increases when a catalyst is used. Choose from the list the element that is most likely to be used as a catalyst. So, the elements which can be used as a catalyst are transition metals. We have to see from the list which one is a transition metal. Calcium, carbon, copper, sodium, sulfur. Copper is a transition element. State the effect on the position of equilibrium when the catalyst is used. A catalyst is something which speeds up the rate of reaction. So, it makes the system go fast, it makes the reaction happens faster, but it does not affect the position of equilibrium. So, we'll write that no effect or catalyst do not affect the position of equilibrium. State the effect that a catalyst has on activation energy. Now, a catalyst lowers down the activation energy. It provides the alternate way to the reactant particles to turn into product. So this is the alternate way by lowering down the activation energy barrier. This was question number 4. We'll do the rest of the questions in the next part. Thank you.